Next is when a point object of a charge q is placed at a distance d from another point charge which is 2q. So there is plus and there is plus 2q. Okay. And it is placed at a distance. The charge is increased to 2q and the charges are increased to 2q and 4q and the distance increased to 2d. Like what we did, the distance was d here between them. Okay. Now what we did, we double the distance. We made it 2d, and the charge is changed from 2q to 4q. Which of the what is the new force? So what is the force between these two charges? That is given by a formula F q1 q2 over r square. So F is equals to k 2q square over d square. Okay. Now in the question, the distance is being double and the charge is also being double. So what happened to the product? As it is F is equals to, this one remains same, the other one will become 4q. And what happened to distance? If a distance is double, like it is 2d whole square. So it will be F is equals to k capital Q 4q divided by 4d square. So if we want to simplify this, if you compare, like this is 4q, this is plus q, the two charges are not one chart. The charges they said, I misread the question. I thought one of the charts, but they mention here charges. So first, when a point charge of a plus q is placed at a distance d from another point charge 2q. So this is another point charge 2q at a distance d. So what about the force? F is equals to capital Q, like q1 q2 over r square. Now in the question, the increases double the distance and double the charges also. The charges are increased to 2q and then to 4q, like 4 times. So if this is 2q, F is equals to q1 q2 over r square. The relation between the product of the charge, if the product of the charge is double, then what will, because now the charges are increased to 2q, like this is 2q, this also 2q. So the product will be 4q. And what happened to the distance? The distance is double. If a distance is double, what happened to the force? The force will decrease by 4 because it is an inverse square law. So it will decrease by 4. So due to the product of the charge, it increased by 4, and due to the increase in the distance, it decreases by 4. So what will happen to the new force? The new force will be same. Is it clear? Because what we did here, first we were having Q and 2Q, okay? And then we have 2Q and 4Q. So 2Q and 4Q. Here the product of the charge was 2. Here the product of the charge is 2 multiplied by 4, 8. So mean this is increased by 4. And what about the distance? Here the distance was d and here the distance is 2d. So because of the distance is double, what happened to the force? So because due to product of the charge increases by 4 and due to the increase doubling the distance reduces by 4. So what will happen to F? It will be unchanged. Next is a turntable playing a vinyl record rotate at a speed of 33 revolution per minute. Angular velocity omega. If we need omega, it's a change in angle divided by time. 33 revolution, we convert into radian because one revolution is 2 pi radian. And how much is a time? 1 minute or 60 seconds. So 33 into 2 pi divided by 60. So it will match with option C. Next is a magnet is dropped vertically through a coil, producing a current in a coil, which creates a magnetic field around a coil. So EMF, according to a Lenz's law, EMF induced always oppose the change in a magnetic field. If we are moving towards, it will try to oppose. So this will be a north, this will be south. So which line of the table correctly shows the pole X of a magnet enter and pole Y when the magnet leave? So first, when magnet enter, because it will, unlike poles attract, repel, like poles will repel each other. Why it will produce a like pole? Because the magnetic field is increasing. This will try to decrease. So there will be a north pole. But when it is leaving, when a magnet is going away, like south and north is going away, so it will try to pull. So this will also be north. Because like if it's moving towards, it will oppose the change, north south. So X will be north, Y will be south. But when it is going away, so it will try to pull. So this will be north, Y will be north, and X will be south. So what about inside? No, when it is actually it's in between, when it is going towards the center, this will happen. When it is going away from the center, so it's like halfway. So till when it is moving toward the center, this will remain north and this will remain south. But when it crosses, because we always compare what is happening related to center of the mass. So we will have the center of the mass of the coil. So if it is moving toward the center of the mass, it will try to oppose. So how it can oppose? This will be north, this will be south. But when it is going away from the center of the mass, when it is exactly at the center, no induce if there is no change in a magnetic field. But it will change drastically. That's how the current direction will change. If you remember the graph, this was a graph. Is it clear?